Hi, this is video number 108 on my series of videos about financial math for Actuarial Exam 2, also called Exam FM. I'm really redoing the content of video number 107 on a spreadsheet, and there are good reasons for that. We are looking at an amortization schedule for a 2-year bond bought at a premium. You're buying it at a price higher than the redemption amount. Why am I doing it on a spreadsheet? Well, for one thing, to emphasize spreadsheet usage. All actuaries should know how to use spreadsheets in the ways that I'm going to show you. And secondly, the content of that last video was kind of hard, and so I thought it would be good to redo the content, rethink about it. I definitely think it's good for you to watch both videos. I'll put a link to that video number 107 here in the upper right corner there, if you want to go back and watch that if you have not done so. So it's the same problem. A $1,000 2-year 12% bond redeemable at par with semi-annual coupons. So the face value is $1,000. It's also called the par value. The redemption amount is the same as that because it is redeemable at par. Coupons are semi-annual, so the coupon rate as an effective semi-annual rate is half of 12% or 6%. They are going to be $60 coupons, 6% of 1,000. This is bought at a premium. You're paying more at time zero than the face value or redemption amount. You're going to pay more than $1,000 for this thing because the semi-annual yield rate of half of 8%, which is 4%, is less than the semi-annual coupon rate. Whenever that happens, you'll be buying the bond at a premium, at least if it's redeemable at par. So we're going to construct an amortization schedule for this. Way to think about this that's helpful is think of you as being a bank and you are loaning money to a corporation or government entity and they have to pay you back over time. Because you're buying it at a premium, essentially you have a loss at the end in a sense. So the coupon amounts are not all interest to you. You have to write down their premium. They are paying more than the interest they owe, technically speaking, each half year. So we need to write that down in an accounting kind of way. We're going to keep track of the book outstanding balances, they're called book values too, just after the coupons are paid at the end of each half year. And we're going to do it in 2 ways, just like we did in video number 107 when we did it by hand with calculator help. Both of these ways we make use of a spreadsheet. In method 1, we are using formulas similar to how we filled in the table in video number 107, the first half of that video, where we used a calculator and we thought about things intuitively. And in this second way, we're going to use the algebraic formulas that we derived in the second half of video number 107. So we'll re-emphasize those formulas. Maybe you didn't write those down before. I think they probably are worth writing down and trying to remember if you're going to take Actuarial Exam 2. All right, so let's start the problem now. So we have the givens that we're going to put in these cells B11 through B14 here. Face value or redemption amount, C, is 1,000. I can just type 1,000 here. I can make this a currency right away of $1,000. As I go through the spreadsheet, technically speaking, more decimal places of accuracy may need to be used, but I'll keep things rounded to the nearest cent. The spreadsheet will keep track of more decimal places that you don't actually see, and so everything should be rounded to the nearest cent accurately compared to what I did in video number 107. The effective semi-annual coupon rate R will be half of 12% is 6%. I'll type that in as a 0.06. I could make this a percent, and the spreadsheet would keep track of it as a 0.06 by hitting this percent button up there, but I think I'll just leave it as 0.06. The effective semi-annual yield rate, J, is half of 8%, which is 4%. And the number of coupons is 4 because it's a 2-year bond with semi-annual coupons. All right, now let's do formulas. Okay, so let's first figure out A and J, just for the sake of showing you how to get it in 2 ways with the spreadsheet. One way, in cell B16, we're going to use the formula we typically use, 1 minus V to the n divided by J. And I think in cell C16, we'll do it another way just to illustrate the use of a built-in spreadsheet function, the equals PV function, standing for present value, to show you that you can get it that way too. But let's type it in as 1 minus V to the 4th over J. V is, of course, 1 plus J to the negative 1 power, the reciprocal of 1 plus J. Let's go ahead and type in 1 plus j here using the cell reference B13 for where j is. I don't need to use that as a fixed cell reference because I'm not going to copy and paste this formula anywhere, so I can just have it as a B13. That is 1 plus j. Raising that to the -1 power would produce v. V to the positive 4 power would be the same as 1 plus j to the -4 power. So I think what I'll do here is put a negative sign now and put B14. The benefit of doing cell references here is that I could make changes to those values and everything would get updated, though I probably, with the tables that I have down here, I would not want to change the 4 in cell B14, but I could change the j in cell B13 and see how things change. Got to divide this by j in cell B13 again. Okay, so I clicked on the cell references to see those come up. You could also type the B13 and B14 as well. So this is going to be an amount a little bit less than 4. It's 3.6298952. This can be thought of as a dollar amount. I'll go ahead and change this to a currency. But again, all those decimal places will be in there. More accuracy is hidden that you can't see. It's, again, the present value of an annuity immediate with payments of 1, end payments of 1 at interest rate j. Let's try this also with the PV function. Equals PV, and by the way, formulas in Excel do, in any spreadsheet pretty much, do start with equal signs. PV stands for present value. You're going to want to, this is kind of small here, you want to look closely at your screen. This first thing says rate. That would be the 4% from cell B13. The next thing after the comma says n per, which means number of periods. That would be in cell B14. The payments are not the coupon payments here. They're not the $60. These are payments of 1. So I want to put a 1 in here, but technically speaking, I need to get the right answer. I need to put a -1 because when you use the spreadsheet function, just like with a calculator financial functions, you want to sort of think of the payments as going out of an account. In this case, it would be the government or the corporation's account to you. I'll put that in there as a minus sign. We don't need to do the future value or the type here. This should give us the same answer. Yes, rounded to the nearest cents, that is the same, and if I showed more decimal places, it would be the same thing. So that's just illustrating the use of the equals PV function. Let's get the price for the bond. This is the premium discount formula, simplified to the case where C equals F. Let's go ahead and use this, and again, I don't need fixed cell references because I'm not going to copy and paste this formula. F is from cell B11. So I have F plus F times R minus J, 0.06 minus 0.04, times A and J, which can come from either cell B16 or C16, right there. Enter that. There we go. 1,072.60, and if you go back and look at video number 107, that is the same price as I got for that video, rounded to the nearest cent. All right, now we're going to go ahead and fill in this table in sort of an intuitive way to start out with, not with algebraic formulas. In the same kind of way I showed in the first half of video number 107. So let's put the starting balance over here first. So in cell F20, I'm just going to pull over the amount from cell B17. And now in this row, I want to think about things intuitively. And I may need to use fixed cell references in some spots and non-fixed cell references in other ones. If you don't know what that means, I'll tell you here in a minute. So first, what is the interest that you would pay, or that the corporation or government entity would pay to you at time 1? Again, the yield rate, the semi-annual yield rate is 4%. It's going to be 4% of the outstanding balance. So as a formula, I want to take the outstanding balance from cell F20, and that I want to be a floating reference because I want that to change as I copy and paste formulas downwards. For example, in C22, I would want that to be an F21. I want to multiply that times the semi-annual yield rate from cell B13, but that cell reference should not get changed as I copy and paste down. So I don't type a B13, I do $B $13 instead to keep that fixed. Technically speaking, it's only the second dollar sign in front of the 13 that's absolutely necessary there to keep row 13 fixed as I copy and paste downward. The first one in front of the B to keep the column fixed is not really necessary, but it certainly doesn't hurt to put both of them in this context. So $42.90, that's my interest at that I get effectively from the corporation or government entity at time 1.5 year. The payment is the coupon amount. That would be F times R, and here I'd want to use both fixed cell references, B11 times B12, and that will be $60. And that'll be the same for cell D22 and D23. And D24, I'm going to add on 1,000 to that because I also want to pay the government entity or the corporation to pay off their balance. Principal reduction, intuitively, I hope this makes sense. That $60 payment to you is overpaying the interest that is owed, so I need to do a subtraction. This thing minus this thing, which would be $17.10, as how much the balance is going to go down after they make that payment. So now I take cell F21 and subtract, or F20, subtract what's in E21. And again, I'm not using dollar signs here because I want these to copy and paste correctly. And yeah, all these numbers are correct so far if you compare them to video number 107. I can copy and paste this downward at least two rows here. And this number, 1019.23, is correct to the nearest cent. Compare it with video number 107. Here I want to copy and paste this down, but I don't want to copy and paste this one down. Well, I guess I could initially here, but let me make a change to this formula. I want to also add on 1,000 to have them pay off the redemption amount of the bond. So the payment here, KT, at time 4 really is going to be 1,060. This can be copied and pasted downward. The principal reduction is going to be 1,000 plus the PR that would come from 60 minus 40.77. So this should be 1,019.23. Yes, it is. I did 1,000 plus 60 minus 40.77. And this can copy and paste downward. Notice these two numbers match. So we're going to get a final balance of 0 at the end. I can do totals with equals sum, built-in spreadsheet function. Add up those interest amounts to get 167.40, just like I did in video number 107. I can copy that formula here to get 1,240 for the total payments to you from the corporation or government entity. The principal reduction amounts I can also add up to give 1,072.60, the same as the initial amount you paid for the bond. What these add up to bring the balance down to 0. And you don't want to add up these numbers, so leave this spot blank. All right, so that's filling in the amortization schedule with method 1. Now method 2 with a spreadsheet with the algebraic formulas derived in the second half of video number 107. Here are those formulas essentially. You may want to pause the video to write these things down. After you've written them down, now I'm going to make use of them to fill in this part of the table. So it's sort of a non-intuitive approach. It's just based on these formulas, sort of a simple-minded thing, not really thinking about where the formulas come from. In the second half of video number 107, I essentially derived these formulas somewhat quickly. And these formulas are useful to, I think, try to remember, perhaps especially this one, to think about principal reductions at any moment in time, and to realize that as time goes by, you keep your principal reduction when you buy at a premium keeps going up by a factor of 1 plus j, the reciprocal of v. That might be the most especially important one to remember. Let's go ahead and use these things now. So here, OB0, I will use this with t equal to 0. Let's see what would be the most efficient way to do this. The best way. F is in cell B11, and now I want this to be a fixed reference because I want to consistently use this formula. B11, that's what I'm typing there, times, or excuse me, plus B11 times R minus J. R is in B12. I'm using all fixed references here, I guess. So far, minus J, which is in cell B13, times A n minus tj. Okay, it might be most useful to use the PV function now. PV, rate is J in B13. The number of periods, okay, this is the tricky part, is n minus t. It's not 4, it's not B14, but it is that thing, B14 minus t, which is going to come from B28, which I do not want to be fixed because I want that to be updated. So I'm going to use B14 minus, with dollar signs, minus B28 without dollar signs. Okay, again, that's n minus t. N comes from B14, and that's fixed. T comes from B28, and that's not fixed because I want that to be 1, 2, 3, 4 in the other formulas. Then a comma, -1, just like before. So take a look at this, compare it with what's over here in cell A27 to make sure it looks right. This should give me the same numbers as this table now as I copy and paste this downward. And it does. For the last one, though, it may not be right because I got the extra payment of 1,000. Yeah, probably not right. Oh, okay, it does 1,000, but then I'd want to subtract 1,000 from that. So I guess I can do this now, minus 1,000. So it's down to 0. All right, so I made use of this one. Now let's go on to this one, starting in time 1. Okay, again, F, oops, let's see, let's go up here. F is in cell B11, which now you can't see anymore. Use dollar signs. Times, I'm looking at this formula in cell A28. Use parentheses. Oops. Go inside the parentheses here. Looking again at A28, I have J, which comes from B13. I have, oh, this is supposed to be in, oh, this is the wrong cell here. Sorry about that. Okay, do it again. So I'm going to have equals B11, it's F times in parentheses, J from B13 plus, looking at cell A28, R minus J is going to be B12 minus B13 times, in parentheses, 1 minus V, which is 1.04 to the -1. Maybe I'll type it in as a 1.04 to the -1. Like that. And just use extra sets of parentheses here. To the, careful here, that's the, looking at cell A28, n minus t minus 1 power, t minus 1 in parentheses, which would be the same as n plus 1 minus t. I'll type that as 1 plus n coming from B14, minus t coming from B29. This is complicated. Do I have the right number of parentheses here? Let's see. I'm not sure. I think I need one more. And maybe another one more here. I hope I've got enough parentheses. Let's see if this comes out right, please. Yes. And that is 42.90 to the nearest cent. Let's go ahead and change this to dollars. So we have a match with that. KT is going to be the same as before. I think I'll just, we don't need formulas for that. I'll just copy and paste this down here. All those there. PR, I can use this formula. So once again, F comes from B11, R comes from B12, J from B13, times the same thing with V as before. That's going to be, let's see here, 1.04 to the negative 1, all raised to the 1 plus n minus t power, t coming from, again, B29. All right, this should hopefully work. 1710, yes it did. Oops, not a percent. Undo that. Change this to $. Okay, so now if I copy and paste these down, they should be correct. These numbers here you see match these. That looks good. Copy and paste these down. That should be correct. These three match these three. It's not going to be correct for the last one here because I have to add on 1,000 to that. Okay, there we go. Now what about the totals for the total interest and total PR? For the total Ks, I can just copy and paste this one. Let's use these formulas for the total interest paid and the total principal repaid to confirm that they work as well. Almost done here. So total interest, N, okay, forgot what cells these are, is in B14. N is in B14. I don't need $signs now because I'm not going to copy and paste these. F was in B11. R was in, what, B12 or B13? B12, I think it was. Plus, I could have factored out an F, by the way, in all this. F in B11 times J minus R. That's going to be negative here. This is essentially a subtraction instead of an addition. J, again, was in B13 minus R, B12 times A and J. Then that was with n equal to 4. I can just use B16 for that. B16. So this is hopefully 167.40, and it is. Almost done. Finally, just this one here. F in B11 times R minus J, B12 minus B13 times, what was it, B16, I think? Yep. Okay, so this should be, this is going to be not including the 1,000, so this should be the 7260. Yep, and then I can add 1,000 to that to make it match the other table. Okay, so I know that's a lot to pay attention to. Probably, if you really like the video, you probably want to watch it again. Actually, maybe I should do one more thing. Maybe I should plot the outstanding balance as a function of time and mention something about it. So let's see. Let's highlight the years and the balances. Same as the book values. Oops, I'm pressing the wrong thing here. There we go. I could make a chart. That's maybe a scatter plot or a line plot. Let's try a line plot. No, that's not what I want. Do that again. Let's try a scatter plot where I connect the dots, maybe with straight lines. And okay, it's going down to 0 because I'm including that one. If I did not include the subtracting 1,000 to pay off the bond at the end, the graph for this fourth point would be up here. And it would look pretty straight. Maybe it does look a little concave down. Technically speaking, the graph is concave down, so to speak, with straight line segments in between. It is just connecting the dots. And essentially the reason for that is because the principal reduction when you buy the bond at a premium here keeps going up each time. So your balance is going down faster and faster, which is essentially why the graph is concave down. And that probably was worth mentioning as well. Thanks for sticking with me here in this video.